Welcome to Unacademy Computer Science. This is K Umamaheshwar Rao. Follow these 4 simple steps to get a 7-day free trial for GATE and ESE plus subscription at Unacademy. Use code KUR75 to get 10% off. Unacademy is conducting Ultra Compact 30 questions, 60 minutes on May 22nd at 11 a.m. Enroll now, quantitative aptitude and reasoning, 30 questions and 60 minutes. Practice for GATE, ESE with Unacademy PYQs. Unacademy's special class features, interactive live classes, polls for the learners, raise a hand option, never miss a class, lecture notes, anytime, anywhere. Unacademy is congratulating GATE 2022 top rankers. Unacademy is announcing All-Star batch for GATE 2023. Batch commences from May 18th. Unacademy is announcing All-Star batch for GATE 2024. Batch commences from May 18th. The features of Unacademy subscriptions: top educators, doubt clearing sessions, study notes, notebook features, test series, either for both plus subscriptions or iconic subscriptions. Additionally, for iconic subscriptions, you have hard copy of study materials, 1:1 live mentorship program, strategy and study program, personalized doubt clearing sessions, live audio interactions during open house. Either for plus subscription or iconic subscription, use code KUR75. Use code KUR75. Price hike is coming soon in GATE and ESE. To get flat 10% off, use code KUR75. Crack GATE 2023 and 24 with Unacademy Lite subscription, mix of topic, subject wise mock tests, access structured test series, detailed solutions and performance analysis. In the previous class, we have discussed Combinatorics without repetitions. Now, today I am going to discuss combinations with repetitions. Combinations with repetitions. Now, the number of combination of combination of n objects taken are at a time number of combination of n objects taken are at a time with repetition is given by n minus 1 plus r CR. Similarly, the number of non-negative integer solutions, the number of non-negative integer solutions of the equation x1 plus x2 plus and so on xn equal to r, where each xi greater than or equal to 0 for I equal to 1 to n. The number of non-negative integer solutions of the equation x1 plus x2 plus and so on xn equal to r, where each xi greater than or equal to 0, where each xi greater than or equal to 0 for I equal to 1 to n is given by n minus 1 plus r CR, n minus 1 plus r CR. Same problem, observe the number of binary strings, the number of binary strings of length n minus 1 plus r with exactly n minus 1 ones and r zeros is n minus 1 plus r CR, which is also equal to n minus 1 plus r Cn minus 1. Understood? Now, problem. For all these three formulas, conclusion is same, n minus 1 plus r CR. Number of combination of n objects taken or at a time with repetition, or number of non-negative integer solutions of x1 plus x2 plus and so on xn equal to r, where each xi greater than or equal to 0 is given by n minus 1 plus r CR. The number of binary strings of length n minus 1 plus r with exactly n minus 1 ones and r zeros is n minus 1 plus r CR. Now, problem, the number of ways of placing the number of ways of placing 10 similar balls into 4 distinct boxes. 4 distinct boxes is 10 similar balls into 4 distinct boxes. So here boxes are distinct, balls are similar. Therefore, this problem can be written as x1 plus x2 plus x3 plus x4, 4 distinct boxes, 10 similar balls where each xi greater than or equal to 0. I mean x1 greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0, x4 greater than or equal to 0. Here n is 4, r is 10. N is 4 and r is 10. Therefore, the total number of possible ways equal to n minus 1 plus r CR, that is 4 minus 1 plus 10 C10, that is 13 C10. 13 C10. Next problem. Number of ways of selecting 10 questions for an examination. 10 questions for an examination from 3 different topics is. Observe here, first topic is x1, second topic is x2, third topic is x3. Total number of questions should be 10. So where each xi greater than or equal to 0. So it is in the form of number of non-negative integer solutions. Of the equation x1 plus x2 plus x3 equal to 10, where each xi greater than or equal to 0. Now here n is 3, r is 10. Therefore, the total number of possible ways equal to n minus 1 plus r CR. N value 3, r value 10. 3 minus 1 plus 10 C10, that is 12 C10. 12 C10 or 12 C2 you can write, because NCR equal to NCN minus R, that's why you can write 12 C2. 12 C10 is nothing but 12 C2. Next problem. A florist sells roses of 5 different colors. 5 different colors. How many bunches of a half dozen? How many bunches of half dozen roses can be formed? How many bunches of half dozen roses can be formed? So here 5 different colors of roses. Therefore, I am converting this problem into non-negative integer problem like this. R1 plus R2 plus R3 plus R4 plus R5. 5 different colors equal to total 6 roses, because half dozen roses. So where each xi greater than or equal to 0. Now here n value 5, r value 6. The total number of ways equal to n minus 1 plus r cr, 5 minus 1 plus 6 c6, 5 minus 1 is 4, 4 plus 6 is 10, 10 c6 r 10 c4, 10 c6 r 10 c4. So final answer is 10C4. Next problem. Number of possible outcomes when 10 similar coins are tossed. Number of possible outcomes when 10 similar coins are tossed. Okay, na? So here, if you toss one coin, possible outcomes are either head or tail. So either head or tail. So two possible outcomes. Understood? So either head or tail. That's why let us say head is x1, tail is x2. x1 plus x2 equal to 10 similar coins where each xi greater than or equal to 0. So here n value 2, r value 10. Therefore, total number of possible outcomes is equal to n minus 1 plus r cr. N value 2, R value 10. That is 11C10. 11C10 is nothing but 11C1. 11C1 is 11. So final answer is 11. Number of possible outcomes when two similar dice are rolled. Number of possible outcomes when two similar dice are rolled. Observe here, x1 plus x2 plus, x3 plus, x4 plus, x5 plus, x6 equal to 2. x1 plus x2 plus x3 plus x4 plus x5 plus x6 equal to 2, where each xi greater than or equal to 0. So here m is number of different possible outcomes, because phase 1, phase 2, phase 3, phase 4, phase 5, phase 6, that is 6. n equal to 6. R value 2. n value 6, R value 2. Therefore, the total number of possible outcomes, because two similar dice are rolled, that's why R value 2. n equal to 6 means if you throw one dice, possible outcomes are 6. 6 different possible outcomes. That's why n value 6. Therefore, total number of possible ways equal to n minus 1 plus r, CR, n value 6, R value 2. Six minus 1 is 5, 5 plus 2 is 7. 7C2, that is nothing but 21. 21. Next one. Next problem. The number of ways of placing 20 similar balls, 20 similar balls into 5 boxes, where each box is non-empty. So if you convert this problem into non-negative integer problem, here 5 distinct boxes. Therefore, x1 plus, x2 plus, x3 plus, x4 plus, x5 equal to 20. Sir, here each box is non-empty. This is another key word. If it is non-negative, thing is different. Non-empty, the thing is different. Non-empty means, non-negative means xi greater than or equal to 0. Non-empty means xi greater than or equal to 1. For all I equal to 1, 2, 3, 4, 5. So, each xi greater than or equal to 1 because of non-empty. Because of non-empty condition, each xi greater than or equal to 1. That's why what we have to do? First you have to fill each box with one ball like this. There are 5 boxes. 1, 2, 3, 4, 5. There are 5 boxes. First we have to fill each box with one ball. Now, n value 5, r value 20 becomes 15, because each box we have filled with one ball to fulfill non-empty condition. Now r is equal to 15, because 5 balls are left over. We have already filled. So remaining, how many balls are left? 15 balls are left. Therefore, by placing one ball in each box, non-empty condition becomes non-negative condition. Now our problem becomes number of non-negative integer solutions of x1 plus x2 plus x3 plus x4 plus x5 equal to 15, where each xi greater than or equal to 0. Now n value 5, r value 15. The total number of possible ways, is equal to n minus 1 plus r cr. N value 5, 5 minus 1 plus 15, C15, that is 19C15, 19C15. Next problem, the number of non-negative integer solutions of x1 plus x2 plus x3 plus x4 equal to 20, where x1 greater than or equal to minus 3, x2 greater than or equal to 0, x3 greater than or equal to 0, x4 greater than or equal to 0. So here x2, x3, x4 are greater than or equal to 0, non-negative condition, but x1 is greater than or equal to minus 3. Whenever minus 3, minus 4 such type of conditions are there, just you have to add that value to r. So here n value 4, x1, x2, x3, x4, therefore n value 4. What about r value? 20 plus, here we have greater than or equal to minus 3, now you have to add 3, 23. So r value 23. Now our problem becomes x1 plus x2 plus x3 plus x4 equal to 23, where each xi greater than or equal to 0. Now each xi greater than or equal to 0 means non-negative. So number of non-negative integer solutions of x1 plus x2 plus x3 plus x4 equal to 23, where each xi greater than or equal to 0. Now n value 4, r value 23, the total number of possible ways is equal to n minus 1 plus r cr, that is 4 minus 1 plus 23 C23, that is 26C23. 26C23 is the correct answer in this problem. Understood? Next problem. The number of non-negative integer solutions of x1 plus x2 plus x3 plus x4 equal to 20, where x1 greater than or equal to minus 3, x2 greater than or equal to minus 2, x3 greater than or equal to 3, x4 greater than or equal to 5. Now observe here, r value 20 plus 3 plus 2 minus 3 minus 5, that is 25 minus 5, 20 minus 3 is 17. So now the given problem is reduces to the number of non-negative integer solutions of non-negative integer solutions of x1 plus x2 plus x3 plus x4 equal to 17, where n value 4, r value 17. The total number of possible ways equal to n minus 1 plus r cr, 4 minus 1 plus 17 c17, that is 20 c17. So correct answer is 20 c17. Understood? Thank you. Tomorrow I am going to discuss a Pigeon hole principle. Thank you.